Yeah, so it's actually software and modular solutions. And several years ago, we kicked off a new investment for Agilent, or a reinvestment back into modular products. About 15 months ago, I was asked to take responsibility for that. And we had a long discussion about how are we going to add additional value in modular and so forth. At the time, I was running our design tools business, our eSoft business. And very clearly to me, that linkage between software and hardware, as we've just discussed, if you can close the loop between design and validation, design and test, that's going to save a huge amount of time through the life cycle. And it's all about engineering productivity. So that's what the division was set up to do. We're focused on modular products. But it's interesting to know that in eSoft, we've had a modular activity for about 3 years, basically modularizing our software, reusing different components across the different platforms that we have. So we're using those same principles to allow us to now introduce more hardware and really to get some better solutions out there for customers. Now, how does that manifest itself in practice, I guess you could say, would be your next question. I'm going to give you 3 examples. Okay. The first is that we're actually using the very same algorithms that you might make a measurement with on an instrument in our simulation environments. So for a number of years, you've been able to take our vector signal analyzer software that could connect to hardware products and actually apply that into the design domain. So you're using exactly the same measurements. There's no difference. And you can correlate them directly between what you measure in simulation, or what you simulate for your test bench, and what you end up measuring in practice, at least the methodology. The second thing we're doing is enabling a series of virtual validation test benches to be created in the RF domain and then reused for validation. So this is the first time I think this has been done formally. It's been a practice that's been used in the digital domain for a long time. So the same test vectors essentially can be used from design through into validation. That saves a lot of rework and a lot of software effort. So you can plug instruments in and essentially reuse those. And finally, what we're enabling is hardware in the loop. So at any point, if you have a piece of hardware that you want to include in the design process, then you can include that hardware in the loop, in the simulation. For example, you may have an existing amplifier and you just want to know how it's going to behave in some new design space. Maybe you've got some different frequency ranges you have to work with, different power levels. Then you can actually simulate those signals, apply it to your real device, and see what the result is in a much more seamless, easy way. So those are just 3 specific examples of how we're trying to tie simulation and design together with test.